Well, here's a short video on ordering, rounding, and dividing decimals. When we're ordering decimals, we could rewrite all of these where we line up the decimal points. We could start that way, and that would help us with place value. But another way to look at this is by taking a look at the individual numbers. Now, what we would look at in this collection of 5 numbers that we would want to order is we could also think of it on a number line. But let's deal with the negative numbers first. Because if we're going to go from least to greatest, we know that the largest negative number is going to be the very smallest number. It's going to be the least of the values. So what we're going to do is we're going to look at the negative numbers. We've got 212 and 3/10, negative 212 and 3/10, negative 88 and 957 thousandths, and we've also got 3 thousandths, negative 3 thousandths. So what we'll look at here is we've got, now we're going to see that relative to the decimal point here, we have something in the hundreds place, a negative. Negative 212 is going to be definitely larger than 212 is more negative than 88 or 0. So we're going to, the very lowest number that we have here, just right off the bat, it's pretty easy, and it's negative 212.3. So that is the most negative. It is the farthest left of all of the numbers on the number line. So with regard to the negatives here, this is also quite negative. Negative 88 is far more negative than 0 is. See, there's a 0, an imaginary 0 right there, just to the left of this decimal place. So we know that negative 88 is larger than negative 212. So this 957 is going to be the next least. So let's make sure that we're being organized about looking at this. So the last of the negative numbers we know is going to be negative 0.003. All right, so now we have the positive numbers, and we're going to look to see which place values are filled here on the positive numbers. We have 30 to the left of the decimal, or we have 4 left of the decimal. Well, 30 is more positive than 4. 4 is going to be the next least number. So somewhere along here was 0, right? So assuming we have 0, now we're in the positive side of the number line, 4.12. And then our last number here is going to be positive 30 and 12 thousandths. So there's the different ways of taking a look at it. You can look at it, you can line them up by place value. You can handle all your negatives first, and remember, the larger the negative number, the farther it is from 0. So the lesser that value is. Or you can put them on a number line and just double check and make sure that that you're ordering them properly. All right, let's go to rounding. Place value, again, is going to be very important with regard to rounding. And so let's just look at this one number, and we'll round it several different ways. Why don't we? And let's make some room for myself. Okay. All right, so let's round this to the tens place. Okay, so where is the tens place? The tens place is, when we look at, it's all relative to the decimal here. So this is the tenths place, which means 1 over 10. And this is the ones place, and this is the tens. So we know that this is the one that we're going to round one way or the other. And this, the ones place, is going to inform us as to whether we're going to round it up or leave it the same. So since this is less than 5, we know that we're not going to change the tens place. We're going to leave it the way it is. So this number would be changed to 210. And we would drop all of the decimals, but we would keep the ones place and leave it as a 0. This number rounded to the tens place is 210. So let's now think about the 10 thousandths place. All right, 10 thousandths is we're going to have to take a look to the right of the decimal. So this is tens, hundreds, thousands, 10 thousandths. This is the 10 thousandths place. So the 100 thousandths place is going to inform us whether we're going to round that 6 up or not. And since it's also going to be a 2, we know that we're not going to change 6 at all. And we know that we're also going to truncate all of the decimals to the right of the 10 thousandths place. So what we do is we rewrite all of these numbers to the left of the 10 thousandths place. 0, 1, 9. And then if we remember, we're not going to change the 6. So this number rounded to the 10 thousandths place is 212 and 196 ten thousandths. So let's see. Let's now change it up and say to the hundredths place. All right, to the hundredths place. Now we're going to say tens, hundredths. So this is what we're going to consider. This is what we're going to be informed by. Hey, we're 5 or above, and therefore, again, all the numbers to the left of the hundredths place remain exactly the same. All the numbers to the right of the hundredths place are either identified as 0, since it's the hundredths place and we're already past the decimal here, they're just going to be truncated. If it were to the left of the decimal, then we would identify it with 0. But since this is a 9, we're going to change that 1 to a 2. We're going to round up, and we're going to truncate that thousandths, 10 thousandths, 100 thousandths, millions, and 10 millions. Right. So those are 3 different roundings of that same, given that same number. All right. So let's think about dividing now. Dividing by decimals is a little bit challenging. So I would say, remember what we know. We know that 3.5 over 1 is 3.5. And we know that every fraction is a division problem. It's the same thing as saying 3.5 divided by 1 is 3.5. And if we were to set that up as a long division problem, we would have the 1 over here, we would have 3.5, and then we'd have 3.5 up top. These are all equivalent statements. And so the reason why I write this is because sometimes when people are given a problem in this form, you don't know exactly how to set this up. And I would say, look at it like it's a fraction. When you say 3.5 divided by 1, some people look at fractions that way. 3.5 divided by 1. Now this is 3.5 divided by 0.23. So now we know how to set this up in long division. And I'm going to set it up in long division so that we can deal with our decimal places. So the 0.23, or 23 100ths, goes to the left. 3.5 comes under here. And so I'm going to erase all of that. So we'll have some more room. And though I recommend that when you're multiplying by decimals that you deal with the decimal shift after you're done, honestly, I would say that dealing with your decimal shift now is better than later when you're dividing. So multiplying is a little different. I deal with it later, but this is division. Make sure that you know where your decimal goes before you go through all of that long division work. So let's move this over and make it 23. That's a much easier number to deal with. In order to make it 23, I'd have to move the decimal over 2 places. And that means that instead of the decimal place going here, first of all, what I would do is add the zeros, and I move the decimal over once and then twice. Now you can add as many zeros as you want, but once we shift it here by 2, you shift it on the other side by 2. That way we're not changing, we're making an equivalent long division problem. So now that we know where our decimal is going, it's going in between these 2 zeros. Now we can handle this as if it were 23. So what we're really doing is 23, we multiplied everything by 100. So this is really, rewriting wise, this is 23 into 350. Well, I'll leave that up the side just so that you understand, assuming that you're not rewriting your problem. So now we can divide 23 into 35. Well, we know that 23 into 35 goes once. We got 23, we get 12 left over. We have 120. And so we know that 20 multiplied by 6 would be 120. So we know that it's going to be less than that. So here's another thing that you could do. Well, if it's less than 6, let's see what 5 is. So here we are with 15, and we've got 115. So we know that this is the right number. So 5 times 23 is 115. We've already got it right here. We've got 5 left over. We carry down the 1, and we'll end up multiplying this by 2 because 2 times 25 is 50. So 2 times 23 is going to be 46. We're going to have 4 left over. We're going to keep going. But what I want you to realize is if we were to go ad nauseum, it's going to be this is going to be 1 because we know that 2 is 46. So the number's going to keep going. What's more important for you to understand is to make sure that you have done your decimal shift before you start doing your division, so that when you get an answer, I think the answer to this is 173913, just because I randomly picked these numbers. This is the most important component of that answer. Hope that helps.